Hello. In this video I want to discuss an example involving the tangent line to a curve given by a vector function. So we have a vector function r of t given over here. So r of t is cos t plus 2 sine t, t plus cos t, and we want to find all the points r of a on the curve given by this vector function where the tangent line, let's call it TA, to the curve at the point RA is perpendicular to a line LA. And LA is the line through RA, right? And it has equation x is r of a plus t 1 minus 1, 1. Right? So what's going on here? Right? So we've got our curve x is equal to r of t. Right? So for a specific value t equals a, we get a point here on the curve. And at this point we draw two lines. First we draw the tangent line, TA, and then we draw this line, LA. Right? Now as A changes, so in other words, as we move along the curve, these two lines are going to shift. And we want to know, when are they going to be perpendicular? At which points on the curve will they be perpendicular? Right. So now we must recall, what do we mean when we say two lines are perpendicular? Well, so we've got the two lines intersecting in this common point, r of a. Now, TA, the tangent line, goes through r of a, and it goes through this point over here, r of a plus r prime of a. Right? So we look at the ray coming from r of a towards r of a plus r prime of a. Right? And then we take the line LA. Right? And again, we've got this point over here, r of a, and then we've got another point over there, r of a plus 1 minus 1, 1. And we look at that ray. Right? And these two rays generate an angle. Right? And our lines are perpendicular if and only if that angle, right, so the angle generated by these two rays, has magnitude pi over 2. Right? So remember, how do we define the magnitude of an angle? Well, the cosine of the magnitude, so in this case that's pi over 2, must equal the dot product of the two direction vectors. So in this case our direction vectors are r prime at a dot 1 minus 1, 1 divided by their magnitude. So norm r prime of a, norm 1 minus 1, 1. Right, so that's how we define the magnitude of an angle. Right, so in this case the magnitude is pi over 2, so the cosine is 0. So we see that our two lines, LA and TA, are perpendicular if and only if this expression here is 0. Right, now remember, a fraction can only be made 0 by making the numerator 0. The denominator never makes a fraction 0. So we see that our two lines are perpendicular if and only if r prime a dot 1 minus 1, 1 is 0. And of course, remember, the derivative of r shouldn't be 0. Otherwise, the tangent line at r of a doesn't exist. And this expression doesn't make sense. So let's check. What is the derivative of r at some a? Well, remember, r of t is given by this expression here, so we just differentiate component-wise. So it gives you minus sine t plus 2 cos t in the first component. In the second component it gives you 1, and in the third it gives you 1 minus sine t. Well, should change the t's here to a's just to be consistent. Right. So if we take the dot product of the derivative of r at a with 1 minus 1, 1, what do we get? We get minus sine a plus 2 cos a right? We get minus 1, and we get 1 plus 1 minus sine A. Right, so that gives you 2 cos A minus 2 sine A. Right. So from this we see that the derivative of r at A, dot product 1 minus 1, 1 is 0, if and only if 2 cos A minus 2 sine A is 0, and that happens if and only if tan A is 1. Now when is tan A 1? Tan A is 1 if and only if A is equal to pi over 4, but now be careful, the function tan is periodic with period pi. So we actually have infinitely many values for A at which derivative of r at A dot 1 minus 1, 1 is 0. All the real numbers A of this form. Right. So, when is LA perpendicular to TA? Well, it's perpendicular to TA at all the points of the form r of pi over 4 plus k pi, and these are cos pi over 4 plus k pi plus 2 sine pi over 4 plus k pi, and then pi over 4 plus k pi, and then the third component we get pi over 4 plus k pi plus cos pi over 4 plus k pi. Right? And this is for any integer k. Now remember that sine and cosine have period 2 pi. Right? So that means we can say cos pi over 4 plus k pi is cos pi over 4, which is 1 over root 2, if k is even, so minus 2, 0, 2, 4, 6, 8, and so on. And in the same way, we get sine pi over 4 plus k pi is 1 over root 2, if k is even. On the other hand, when k is odd, the sign is going to change. So cos pi over 4 plus k pi and sine k over 4 plus k pi will both be minus 1 over root 2 if k is odd. Right. So from this we see that TA and LA are perpendicular at the points r of pi over 4 plus k pi, and that will be 3 over root 2 pi over 4 plus k pi over 4 plus k pi plus 1 over root 2. That's for an integer k that's even. And on the other hand, we'll get the points r pi over 4 plus k pi minus 3 over root 2 pi over 4 plus k pi over 4 plus k pi minus 1 over root 2, for k an integer, k odd. Right. So we see that there are infinitely many points on the curve where the lines TA and LA are perpendicular.